This video is a review of trigonometry, which is about finding a side of a triangle given the angle and another side of the triangle. We can use sine, cosine, and tangent to find missing sides of a triangle given another side and the angle of the triangle. I'm not going to run through these three steps. You can read them on your own. I'm just going to give you a few examples of using them. Just as a reminder, your trig identities appear here on your calculator, sine, cosine, and tangent. And before you use these, please make sure to hit mode and make sure that your calculator is set to degrees rather than radians. That's a very common mistake. Okay, so let's look at this first example. So I've got a triangle with a hypotenuse of 10 and an angle of 30 degrees, and I'm trying to find that missing side on the right. So I'm going to go through these steps. Step number 1, determine which trig identity to use. To do this, determine which side of the triangle you know and which side you're trying to find. The trig identity that has both is the one you want to use. So here I can see that I have the hypotenuse and we need the opposite side. The 10 is the hypotenuse and the thing we're trying to find is the opposite side. And the only identity that connects opposite and hypotenuse is sine, so we'll use sine. The second step is to rearrange the trig identity so that the side you're trying to find is on one side of the equation and everything else is on the other side. So here I'm trying to find the opposite side of the triangle. So if I rearrange this equation so that opposite is by itself on one side, I'm going to start by multiplying both sides by hypotenuse. Those go away. And I get that the opposite side is equal to the hypotenuse times sine of the angle. The last step is to plug in the values you know into your identity and solve. So when I plug this in, 10 times sine of 30 degrees is equal to the opposite side. And when I plug this into my calculator, I get the opposite side is equal to 10 times 0.5, which is equal to 5. So that's how you find the missing side of a right triangle using trigonometry. So this would be 5. Example number 2, I'm going to follow those same steps. Here I have the hypotenuse and the adjacent side. So the only thing that connects hypotenuse and adjacent is cosine, so that's what I'm going to use. And because I'm trying to find the adjacent side, I need to rearrange that equation to get adjacent by itself. This is what that looks like. And finally, plugging in my numbers, 10 times cosine of 30, according to my calculator, is 8.7. So that will be the length of the opposite side of the triangle. Example number 3, you can see this time we're trying to find the hypotenuse and we have the opposite side. The only thing that connects those is sine, so that's what we'll use. And now I have to rearrange that for the hypotenuse to get the hypotenuse by itself. And this is what that looks like. The hypotenuse is equal to the opposite side over sine theta. Finally, I'm just plugging in my values. The hypotenuse is equal to 8 over sine of 60, and according to my calculator, that's 9.2, so that's the value of the hypotenuse. Example 4, I have the opposite side and I'm trying to find the adjacent side, and the only identity that connects those is tangent. So using tangent, I'm trying to solve for the adjacent side, so I'm going to rearrange this to get the adjacent side by itself. This is what I get. Plugging in my numbers gets me an adjacent side of 4.7, so that's my answer there. Example number 5, I'm trying to find the hypotenuse using the adjacent side. So cosine connects those. Rearranging cosine to get the hypotenuse looks like this. And plugging in my numbers looks like this. So the hypotenuse is 51.5. Example number 6, I have the adjacent side and I'm looking for the opposite. Tangent connects those two. Plugging in my numbers and solving for the opposite side gets me this. And plugging in my specific numbers gets me an opposite side of 13.5. So that's how you use trig to find the missing sides of a right triangle.